Okay, hello. So we're gonna do examples of Fourier series. So to start with, example one. Example one. We're gonna do if phi of x equals x in on the interval 0L, express phi of x as a Fourier sine series. Okay. So we'll do a little graph in a second. Okay, we'll see this how this is gonna work very nicely. So you have phi of x equals x between 0 and L. Notice L is any interval. Okay, so I want to find a Fourier series that approaches to this. So I want to find basically it's gonna look something like this. It's gonna get close and then connect like this. Okay, we'll talk later about periodicity. So then this Fourier series can be extended periodically. Okay, so when we extend it periodically, this is not yet, so it goes like this, and then the series you're gonna see when you graph it is gonna go like that, and then goes down and so on. Okay, so but that's gonna be later. For now, we are just doing between 0 and L, just like the Taylor's theorem. Taylor's theorem is on an interval. Okay, so this is similar to, in that sense, to Taylor's theorem. Okay, so this is easy. If we have phi of x, we have a formula, right? Phi of x equals a sum of n equals 1 to infinity a sub n times sine of m pi x over L. Okay, and a sub n is we already defined it, 2 over L integral between 0 and L of phi of x, or whatever function I have, is sine m pi x over L dx. Okay, so that's my formula. So let's do it. So I need to find a sub n. So a sub n, as we already wrote it, is 2 over L phi of x times sine of pi of x. So but what is phi of x? So phi of x, so we have 2 over L integral between 0 and L, and phi of x is x. So we got x times sine n pi x over L dx. Okay, so now we do integration by parts. We need to find that using integration by parts. So we do u equals x, dv equals sine n pi x over L dx, right? Why I choose this integration by parts? Because when I find the derivative of u, I got 1 dx. So that's something you learn in calculus too, right? You want to eliminate that. You make it integration by parts, supposed to make things easier, not harder. Now this one, you need to find b. What is the antiderivative of sine n pi x over L? So you know So please stop the video and think yourself, because that's gonna happen. You're gonna use it all the time. So I will be proud of you, and you can do this by yourself the first time. So stop the video. Now you are coming back. So this is cosine. The antiderivative, the antiderivative of sine is actually minus cosine, right? M pi x over L. But so let's see. If I find the derivative of cosine is minus sine, so times minus is sine, n pi x over L, times the derivative of the inside. The derivative of the inside is n pi L. So this one doesn't have n pi L, so I need to divide by that. So I need to divide. So I have to get minus L n pi, right? Now check again. The derivative of this, the derivative of cosine is minus sine, so times minus is sine, n pi x L, times the derivative of the inside, that will give you n pi L. So n pi cancel with n pi L, and then you got it. Okay, so that's my first integral. Now I can do integration by parts, so let's do it over here. A to n equals, so 2 over L. So on this you have to be careful. Do it slow, don't try to skip steps, because this is fine if you go slow. If you start going fast, you're gonna make mistakes. Okay, u times b, that's gonna be minus x times L n pi times cosine n pi x over L, and this is between 0 and L, right? This is between 0 and L, minus the integral of b du. So b du, so remember integration by parts, right? So the integral of u db is u times b minus integrals of b du. Okay, that's what I'm using right here. So this is u times b, u times b, u times b minus b, so that one is minus L n pi cosine n pi x over L minus b du will be dx. Okay, so I get and all this is multiplied by 2 over L. So I get a to n equals, so I will replace, so sorry, this is between 0 and L, right? So let's replace this guy. 2 over L. So if I replace L, notice what happens. Minus x L over n pi times cosine n pi L over L, and then minus, so that will be plus, I plug in 0. That 0, I replace by x by 0, so 0 times cosine is going to be 0. So let's save time. So that's going to be 0, right? And then I got minus and minus is plus, so let me put it here, plus, let me take these guys out, L n pi. So what is the antiderivative or integral between 0 and L of cosine n pi x over L? We can also do it in our head, right? So we got minus sine, in this case sine, right? Sine, the derivative of sine is cosine, so minus and minus is plus, so it's possible that I make a mistake. So if I make a mistake, be patient, and at the end I will compare, and then if I have it wrong, I will try to find a mistake. So sine of n pi x over L, sorry, that L is really bad. Okay, and then the derivative of this should be cosine n pi x over L, and then I had to again that the derivative of these guys will be n pi over L, so that one is not there, so I need to divide, multiply times L and pi. Okay. And this is between 0 and L. I cannot regret of using that L, but anyway. Um, so let's see. So let's keep going. So I get, it looks like I have a mistake somewhere. Well, let's keep going. So I got 2 over L, and then sorry. When I plug in the L, I didn't replace this L, right? So L. Okay, now it looks better. So let's do this one. L minus L times L is minus L squared divided by m pi. Now L cancels with L, right? So what is cosine of m pi? So look at cosine of m. This is cosine. This is cosine of 0. No, sorry. This is cosine of 0. Right. So cosine of 0 is 1. This is cosine of pi. So this is pi is minus 1. This is 2 pi. So it's going 1 minus 1, 1. You see? So let's keep going to see if I convince you. This is 3 pi. And this is 4 pi. So when it's odd, it's negative 1, and with it's even, it's positive 1. So what do you want to do? So this is probably minus 1 to the n, right? So if it's odd 1, if it's 0, 0 is even, so it's 1. If it's 1 for pi, I got minus 1. If 2, I got positive 1, so on. So this guy is minus 1 to the n plus, and then when I plug in here, so L squared n pi squared, but then I have sine m pi L over L. This is L over L cancel, and sine of n pi is 0. This guy is 0 for n. Okay, for this n, this is 0. Then minus, when I plug in x at 0, I'm gonna get 0 too. So this guy, the whole thing is 0. So just do it slow, okay? Just convince yourself that you know it. So I wanna give you like also what you're supposed to do. You wanna spend a lot of time doing this, right? So this is fast to do. So I'm getting 2 over L minus L squared n pi minus 1 to the n. That's what is a to the n. When I cancel, I get, and this minus times minus this guy, I get 2L n pi minus 1 n plus 1. Two L n pi, oh sorry, not 2 pi, n pi minus 1 n plus 1. In conclusion, I have that, in conclusion, you can approximate x on the interval 0L as the sum I mean, I guess you can factor 2L n pi, right? You can factor this 2L n pi. So you can get 2L pi sum n equals 1 to infinity minus 1 n plus 1 divided by n, right? So I copy. Then this is my a sub n. Well, okay, let me put it like this. This is 2L n pi, right? So that's my A sub n. This is A sub n. And I follow in my formula. My formula is A sub n times sine n pi x over L. So I put times sine n pi x over L. So now that you see it, that's A sub n, so I'm gonna take it out. And then I take it out, is 2L over pi. Okay? So let's stop it here.